Hello and welcome to all. Today we will discuss about the application of conservation of energy to a simple pendulum. Here is a simple pendulum, diagram of simple pendulum, in which this is the bob of mass m, which is attached to a string through a point O. Initially, bob is at rest condition at the point A. If we displace this bob from its rest position to point B, then there is a gain in energy takes place, which is in the form of potential energy of the bob. At point B, the height of point B from the datum line or reference line which is passes through point A is h. This is the height of the bob at point B from this reference line. Then at point B, the potential energy obtained by bob will be equal to mgh. This is the potential energy of the bob at point B. And if the bob is released from the point B, then it again reached to at point A, then there is decrease in potential energy, because when the bob moves from B to A, the height of the bob is decreases from h to 0 at point A. Therefore, the potential energy at point A will be 0. During the motion of bob from point B to A, there is decrease in potential energy of the bob, which results in gain in kinetic energy. Now we know that as from the conservation of energy, the total mechanical energy of an isolated system is conserved. It only changes its forms. Here, the total mechanical energy at point A will be equal to total mechanical energy at point B. And we know that mechanical energy is the sum of potential energy plus kinetic energy. Therefore, potential energy at A plus kinetic energy at A will be equal to potential energy at B plus kinetic energy at B. Here, potential energy at A is mgh, but at point B, the bob is at rest position. Therefore, kinetic energy of the bob at point B will be 0. When the bob is released from the rest at from point B, then there is gain in kinetic energy, which is equal to the loss in potential energy of point A. Therefore, from this equation we can write here potential energy at point A. Here at point A, the h is 0, therefore potential energy will be 0 at point A, and kinetic energy will be equal to half m va square. This is the velocity at point A, will be equal to potential energy at point B. This is mgh, and the kinetic energy at point B will be 0. Therefore, from this equation we can obtain the formula for VA, velocity at point A. Here m and m is cancelled, and VA square will be equal to 2GH, and VA is equal to under root 2GH. The velocity at point A is calculated by the conservation of energy principle applied between point A and B, and due to gain in kinetic energy at point B, it moves up to point C, which having the similar height of point B, that is H. Therefore, total mechanical energy at point C will be equal to the mechanical energy at point A, and there is loss in kinetic energy during motion of bob from A to C, and gain in potential energy, that is the loss in kinetic energy of bob will be equal to gain in potential energy of bob at point C, and this is at point A. At point A, the total energy is the half mv square, and at point C, the kinetic energy will be 0, because at this point the velocity will be 0, and potential energy will be equal to mgh. Therefore, we can write here, if we assume that this height is assumed to be hc, then potential energy at point C will be equal to mghc, and the gain in potential energy at point C will be equal to the loss in kinetic energy of point A, and the kinetic energy at point A will be equal to half mva square. Here this is then we have to calculate that this will be equal to 2gh, or root 2gh square will be equal to 2gh. Here 2 is cancelled, then mghc will be equal to mgh. Here m is cancelled with m and g is cancelled with g. Therefore, hc will be equal to h. This proves that the height of bob at point B will be equal to height of bob at point C. This is the application of conservation of energy for simple pendulum. It means that the total mechanical energy at A will be equal to total mechanical energy at B will be equal to total mechanical energy at C. This is the conservation of energy principle. Now here is a question related to conservation of energy principle. A body of mass 10 kg is kept at a height of 5 meter. It is allowed to fall and reach the ground. The first portion of the question is, what is the total mechanical energy possessed by the body at the height of 2 meter? And second part of the question is, what is the kinetic energy possessed by the body just before hitting the ground? Here it is given that we can take g equal to 10 meter per second square. This is the acceleration due to gravity which is used in this question. Here is the diagram for the question with given data. It is given that an object of mass 10 kg is kept at a height of 5 meter. This is the height of this object from the ground. This is the ground. From the ground, the height of the object is 5 meter given, and it is allowed to fall and reach the ground. It is allowed to fall. It means that the velocity at point A will be equal to 0. Then at point A, the total mechanical energy of this object is its potential energy, and the potential energy of the object at point A will be equal to, as from the formula of potential energy we know that potential energy will be equal to mgh. Here m is given 10 kg, g is given 10 meter per second square, g is given in this question here 10 meter per second square, and h is 5. This will be equal to 500 joule potential energy at point A. Now the first part of the question is said that what is the total mechanical energy possessed by the body at the height of 2 meter. Then from the conservation of energy we know that the total energy of the body is conserved. Then if we want to calculate the total mechanical energy at height of 2 meter, then total mechanical energy at point 2 will be equal to total mechanical energy at point A, and at point A kinetic energy will be equal to 0. Therefore total mechanical energy at point A will be equal to the potential energy at point A, which is 500 joule. Therefore the total energy at point B will also be equal to the 500 joule, and at this point it possesses both potential energy as well as kinetic energy, and total mechanical energy at point B, which is at 2 meter from the ground, will be equal to half m vb square plus mghb, and the total mechanical energy will be equal to 500 joule. Here in this question only ask about the total mechanical energy at this point. From this equation we can calculate the velocity at point B, but there is no need to calculate for this question the velocity at point B. Therefore the answer will be equal to the 500 joule. This is the answer of first part of the question. And the second part of the question is, what is the kinetic energy possessed by the body just before hitting the ground. Then as from the conservation of energy we know that the total energy of this mass m is constant at point A, at point B, and at point C. That is, the total mechanical energy at point A will be equal to the total mechanical energy at point B will be equal to the total mechanical energy at point C. This is the conservation of energy. Conservation of energy. Then we can say that if the object allowed to fall from point A, then there is a loss in potential energy and gain in kinetic energy takes place at point when the object reached at point C or the ground. Then the height at point C is equal to 0. Therefore the potential energy at this point, at C point, will be equal to 0, and at point C the loss in potential energy of object which is fall free falling from point A will be equal to the gain in kinetic energy at point C. Sorry. Therefore the potential energy at point A will be equal to mgh will be equal to half m vc square, and the potential energy at point A is 500 joule, and this will be equal to the kinetic energy at point C is 500 joule. Therefore the kinetic energy at point C will be 500 joule. This is the answer. This is the question which is asked in the previous year board examination. In next lecture we will discuss some more examples which were asked in the previous year. Then we will start new topic. Thank you.